Okay, welcome to another exciting semester. This is ECE 420, Readings in Electrical and Computer Engineering. My name is Professor Lyon, and everyone here should have a syllabus. What's your name? Anup? Anurup. Anurup is in charge of making sure everybody has a syllabus, so if you don't have one, you can thank him now. So what I thought I would do is go through the syllabus and maybe give everybody a little insight into what the course is about and what is expected of you in this course, so that you will not be surprised by anything. And if this is not the course that you expected, well, perhaps this is one of those things where you should think about whether or not you want to be in the course. So what I'll do, you have a printout in front of you of this syllabus, which I'm putting up, and the basic outcome of the course is you will write a thesis proposal. It will not be a thesis. It will be a proposal to do a thesis. And so it is a writing project which makes reference to prior work in the field, which means that you need to do research. And by research, what I mean is you have to look at other people's work, you have to be able to cite it properly, you have to be able to position your work relative to other work in the field. And so what you are in now is a technical writing course. And so if your English is not so good, or if your writing is not so good, it will be better by the time this course is done. And that's one of the reasons why this is a required course. Graduate level, required course for the ECE Master's Program. You also must complete this course and get a B or better if you want to go on for a thesis. That is a necessary but insufficient condition for doing a thesis here. In addition, you must find a thesis advisor. And that thesis advisor has to be interested in your work. So you cannot just go up to somebody and say, "You're my thesis advisor," because they will say, "Who are you? And why should I be your thesis advisor?" And they say, "Oh, please, 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 please." No, you have to have someone who cares about your work. So if you said, "I want to do work in," make up a topic, active suspension systems. You could say, "Well, that's a very interesting topic, but it's not my area. I cannot be your advisor." Right? And that's true for me. I couldn't advise you for active suspension systems, but maybe we could find somebody in the mechanical engineering department who could help. Or maybe we could find somebody, maybe even in industry, who could help. So if there is someone who is really interested in, let's say, vibrations for helicopters, I can say, "Well, that's a very interesting idea, but I know nothing about vibrations in helicopters. However, I have a company, Sikorsky, which makes helicopters, and there are people with PhDs at Sikorsky, and they can be your advisor." So you can have an industrial advisor, not here, but the person who that industrial advisor gives the grades to has to be a faculty member. So the entire arrangement has to be done within the School of Engineering. So I can go to Dr. whoever over at Sikorsky, and I can say, "Would you be willing to be this student's advisor?" They may say yes. If so, then they will work with you, and they will review your work, but they will submit the grades to me so that I can make sure that you get grades from Fairfield University. So at the end of the day, once you do your thesis, you'll do a thesis defense. You'll present the thesis. Part of this course is to hone your presentation skills. If you've never presented before, your technical ideas, your technical proposals, this is the time when you get to learn how to do a technical presentation. It's so important. I cannot tell you how important it is. If you want to lead in an industrial setting, technically so that you can pitch your product, so that you can take your ideas and move forward, so that you can call the shots in your research. You must be able to present your ideas coherently. Management will not fund your ideas. No one will follow you. No one will essentially look to you for leadership unless you can do a cogent presentation of your own ideas in a convincing fashion. In industry, when you present your ideas, they have to look like they're going to yield some sort of return on their investment. And you are going to be asking for resources. And these resources may include people and equipment and a budget. And you will have to prepare these proposals in order to be able to present them coherently and eloquently so that they become funded. This is also true if you decide to move on into the area which I like to call engineering entrepreneurship. Engineering entrepreneurship means taking innovation and commercializing it. The commercialization of innovation enables innovations to have impact. If you work here in a university and do nothing else with your work, you will produce papers, maybe patents, maybe prototypes, but your societal impact will not be very good. No one will have ever heard of you. However, if you take what you have created and turn it into a product and create a business that thrives, then people will know about you. So this in and of itself is one of the ways in which we as engineers can have impact in society. So when you think about what is readings in ECE really about, it's really about something which is going to serve you throughout your entire adult professional career. This is the skill that sticks with you. This is the reason why engineering can become so exciting. And so I say that when you think about the kinds of things that you can do to contribute to society, to make a difference in your life, this is it, right here. This is where it starts. And so, yeah, it's a writing course. Yeah, it's a little bit of paperwork. But it's giving you the kinds of skills which I think make this field very exciting to me, and which I hope make it exciting to you as well. So that's part of, I'll call it the pep talk about the electrical and computer engineering readings course and why it's a required course. The only required course by name. The only one. You have two other required courses here. You have general programming, graduate programming elective, and you have graduate math elective. Right? And they're restricted electives, and there's a set of courses you can take, and maybe others with permission. The other thing I'd like to point out is if you have questions, I do not prefer formality in this class. Just interrupt me and ask your question. I much prefer that than students who sit like lumps on bumps. It's not correct. I'd much rather have you ask questions. As far as the syllabus is concerned, there are certain aspects to the syllabus which go to grading. And everybody is interested in how do I grade this course. Well, there are three elements, primary elements to the course in terms of grades. The first is homework. The second is midterm. And the third is final. Each one of these things counts for 1/3 of your grade. Homework is so important that I count it for 1/3, which means every time you have a homework assignment, it will be graded. There could be perhaps 10 of them, maybe more. And when these things are graded, they will be graded based on your writing. So if you feel like your writing needs copy editing, have someone else look at it before you submit it. And then if the writing is poor and there's a lot of copy editing that has to be done, it will be reflected in your grade. So our goal here is to improve your writing. Let's see now. I'll show you some sample thesis work. I'm going to show you the website that supports this course, but before I do that, let me go through some of the basic objectives and outcomes for the class. If you've never done research before, let me tell you this. No one is born knowing how to do research. You didn't come out of the womb and said, I'm going to be a researcher. It didn't happen that way. So research is something you have to learn how to do. And what that means is you're going to learn how to do research by actually doing it. I'll show you some examples, and then you're going to go off and you're going to do it yourself. And this may mean using the library, may mean using journals and conference proceedings, and perhaps some books, other relevant material, but it's not just going to be Googling off the web. Okay, it's not just a bunch of, oh, I'm doing research. I type something in Google and I hit enter, and that's research. It's not sufficient. Okay? You're going to have to learn how to use the databases in the library. We may even have some guest lectures come in, and they will give us some guest lectures on how to use our library system. There are certain things that engineers know how to do. A formal problem statement. No one is born knowing how to make a proper engineering problem statement. And you'll know how to do it by the time the course is done. We already talked about technical writing. I'm very interested in making sure your writing looks professional, that it is grammatically correct, that you will do yourself proud when you go into industry and you start to write things like memos and technical reports, and people will not look at this and go, well, it's okay because their English is a second language, or it's okay because they're trying, but, you know, So when that happens, it taints your work, and you don't want your work to look that way. And I don't want to have a phone call from industry that says, oh, this person just can't work very well in an English language speaking culture, because that's not good, and they don't want students like that. They want students who can mesh well in industry. So that's important. There are these things which we call ethics. Okay. Ethics are not morality. Ethics are not right and wrong. Ethics, from a professional point of view, are little more than rules of behavior for engineers. And these rules of behavior for engineers are given to us by our societies. They lay them down for us, and then they give us case studies so that we can look at these things and try and make decisions about ethics. Let's see what else we can do. Students will need to write a thesis proposal, and I gave you a little URL, and if I click on it when I'm in Word, what can happen? Word doesn't open it. I don't know why. So I have to cut and paste these URLs into my how do we call it, browser. Let's see now. Students are required to do presentations. Students will have a research plan. Students will keep a notebook. We already talked about the 1/3, 1/3, 1/3. If you're going to miss class, I would say that you should definitely make up the work by looking at the recordings. I'm going to try and record all of the lectures. It turns out one of the things that we'll do is we'll visit the web page where these lectures will be stored, and then you'll see a way to get updated when the web page changes. I don't always upload the lectures immediately, right? Usually it takes a little time for me to do it, perhaps by the next day. Let's see now, what else do we have? I'll say this about student learning outcomes in the Bloom taxonomy. There is this thing called a Bloom taxonomy which tries to categorize how people learn. Understanding, application, analysis. We've been asked, all of us as faculty, to try and identify these techniques which we are using in order to establish learning in our classrooms. And so what I have done is I have identified these things in a table, talked a little bit about the student outcome, how we'll assess your work, and what the strategies are for presenting. And these letters in here are what are called student ABIT outcomes. ABIT is the Accreditation Board for Engineering Technology. And if you want, you can Google that, and see what the ABIT outcomes are. These letters all have meaning. For example, letter F is the ABIT outcome for ethics. So there's an ethics component to this course, and so there is some, I'll call it, ethical student outcome. The outcome is you will be able to learn how to apply engineering ethics, and there will be examples of this application for you. So these elements, I think, kind of make the structure for the course. What else do we got in here? I think, oh, yeah, it turns out we're not in BANA 133 anymore. I don't know if you noticed. We're in, where are we? Oh yeah, if you have a syllabus that I've handed out in paper, you'll see that we're in BANA 127. So this should be changed, but I can't do it here because it's a pasted in element. So BANA 133 is where my other courses are. And what else do we need to know? And that's it. Are there any questions? You guys are awfully quiet. So I got a little list in here. I thought what I'd do is introduce you to my little website. So this is docjava.com. What I'll do is I'll start at the top. If you go to the docjava.com website and you go in under courseware, you can see the readings course is right at the top. And if you go in through here, you can find all of these lectures which have been recorded from a prior semester. So they're already up, but of course they're a year old. And if you go down to here, you can see there are, I'll call them widgets. And one of the widgets is monitor this page, so that when I change the page, you get an update. That's really a very good thing to do. Within 24 hours, you'll get an email. So I'll put it in lion@docjava.com, and then I'll click OK. And in principle, I should be able to get a URL that comes up that essentially prompts me to get an alert on this page whenever it changes. So this is what they call changedetection.com. It goes out, pulls the web page, checks for changes from last time, and if there are changes, it sends you an updated email. That way, I don't have to be sending out emails. Plus, you can use whatever email you prefer. The school assigns you an email, fairfield.edu. Okay. Probably everyone here has an email that isn't fairfield.edu. If you want the emails to Blackboard, which I'm using for this course management system, to come to you, you have to call Computer Network Services at 4069. And I put their name up here on the whiteboard. ITS, Information Technology Services. And ask them how you can get your email forwarded to your regular email address. So if you have something not fairfield.edu, and who doesn't, then you'll probably have to get your email forwarded. And they will tell you how to do that. I think they have to do it for you. That's kind of too bad, because I'd prefer to do it for you. But I can't. If you want to, you can also join the Yahoo group, which I will use as an alternative to the Blackboard. When I send an email out to Blackboard, it's because nobody has joined the Yahoo group yet. So I can join the Yahoo group. I think I'm already in it. And this will allow me to subscribe to the Yahoo Readings group. And you can use whatever email you want for that group. So in some sense, we're trying to bypass Blackboard as much as possible, but there are certain things which you're going to need to do in order to be able to do your homework and submit your homework to the course. And I don't know why the Yahoo group isn't coming up, but if I click in here, it should work, right? Or not. having a bad day. Let's try and get into Blackboard. That should work. Yeah, that works. So in Blackboard, what I've done is I've already created a first homework assignment, and it's due next week. It says here, please wait while the module loads. So right now, Blackboard is being very slow. Oh, there it is. Aha. That's good. So here's readings in ECE. This is our course. Yeah, come on in. Here's the, oh, you want to pick up a syllabus. Here's the, there should be some course content. And here's a homework. Now, you can read this homework. I'll read it to you so that you have some idea as to what it is that's due. I want you to do, this is a writing assignment. Your first writing assignment due next week. And you'll submit it using Blackboard. And the grade will be submitted back to you also using Blackboard. Blackboard will tell us if you have submitted this assignment late. Let me tell you a word or two about lateness. You lose 10 points per day late on your homework assignments, and that's big. So don't be late with your homeworks. And since homework counts for 1/3 of the grade, it's important that you keep up with your homeworks. This is not a particularly difficult homework assignment, but what I'm asking for is that you come up with some ideas. Now, everyone will have different ideas. No two people will have the same ideas. So this is a case where it's okay to help each other, but you can't both have the same thesis. That wouldn't be good. One of the things about a thesis is everybody has their own. So your thesis topic cannot be somebody else's topic, especially in the same class. Right? That wouldn't be correct. So what would be an example of a thesis topic? I'll go through some examples that we've done with prior work, and I've done full thesis work, and I've done every one of the readings classes for the ECE Master's program. So your basic goal is to find a title for your thesis. You will describe the problem. You're going to motivate the problem. Why is it an important problem? Why should we care about the problem? You'll be talking a little bit about the impact of your solution and some ideas about how you will approach the problem. So these are the kinds of things that we'd like to see written out. You can have more than one idea. Absolutely okay to have a couple or four, maybe no more than that, I think. You'll probably want to focus on just one or two ideas. And if you already have an idea, that's great. You can sort of jot it down right now if you like, and you can write it up and then submit it. If no one here has ever used Blackboard before, this is one of those things where you're going to need to be able to log in to the Blackboard system. It's usually done by going to fairfield.blackboard.com, and then you put in your StagWeb ID and your password. Does everybody have a StagWeb ID? Yes? 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 You didn't get one yet? You will get one. Okay. Yeah, everyone should get this because you probably have one if you registered.
Yeah, I registered, but there's some error.
There's an error? Okay. Well, yeah, we gotta get everybody involved with getting a StagWeb ID. It's so important because I'm using that to process the homeworks, and so this is your grade, right? Very important. Feedback from me goes into Blackboard. Your homeworks go into Blackboard. The grades are going into Blackboard. It's a course management system. And that's good and sometimes not good. I don't use Blackboard a lot, so it takes me a little getting used to as well. So together we'll get through it. I used to use a different system, but they have forbidden us to use it now. So now we're on Blackboard. That sounds terrible, doesn't it? But what are you going to do? So now I'm going to go to my DocJava website, and then I'm going to look at this courseware here. And if I scroll down onto the courseware, I can see, aha, there's this area in here called thesis work. And in thesis work, I can see some completed thesis work. Not every thesis goes on the website. Some students prefer not to publish their thesis. Some students consider their thesis to be proprietary and none of anybody else's business because they want to build a business on their thesis. So, okay, we won't publish. I don't care. It doesn't bother me. You don't have to publish the thesis. And here are some thesis proposals. And not all the proposals have been put up, but these are a few. And so you can look at some of these proposals if you like. And then there's basic questions. How do I write a thesis? Get an A- or better. I think we got it up to B or better. Select a thesis advisor, create a research plan, write weekly progress reports, outline how you will validate your hypothesis. We'll talk more about that later. Create an outline so that people can get your writing and put it together properly. Follow the directions for technical paper. And I've got a few other notes in here. And I've got a sample paper. Here's a sample paper. Oh, I wrote that. This is a paper on parking cars. I did my PhD thesis on parking cars. Don't laugh. It's not funny. Stop it. Stop the laughing. Okay, you can laugh. So there's well, you think it's so funny? You write your thesis on something or other. So anyway, you must understand the car parks itself, right? So it's an autonomous land vehicle. It's not just about parking cars. Okay, you could probably have parked a car when you were in high school, but this is one of those things where the car is parking. So you know, like the Google car, which drives around on its own. That's me. Or the Lexus, which parks itself. The Japanese were very interested in this stuff. It got published in Japanese Society of Mechanical Engineering. And then they took away the automatically parking Lexus for some reason. I don't know. I think they wasn't so popular. So anyway, we have a basic structure, problem statement and motivation, and then some approach information and lots of equations and other good stuff. So let's get out of this thing. Sample paper. Okay. Are there any questions? You're all so quiet. All right. When I do this course, I would like to take a break at some point. When we go on for about an hour, we'll take a little break, and then we'll come back and wrap things up. The course goes from 5 to 7:30, and we may stop at around 7:20, depending upon how long the breaks are. I'll try and record every course and put it up on the web page. Let's see what else. You got the intro to Blackboard. You got to map your email address to the Blackboard address. We talked about lateness for the homework, 10 points per day late. Interrupt me if you have questions. I talked to you a little bit about sample thesis work. The outcome of this course, everyone will write a proposal, everyone will do presentations, and I need you to get a B or better in this course if you're going to do a thesis. So important. And that's my contact info. If you don't already have it, you should jot it down. It's also in the syllabus, which I've distributed. we'll be reading. We'll be reading a lot. We'll be reading 3 or 4 papers per week. There'll be probably at least 45 papers in a term, minimum, that'll be reviewed by you and written about. So you'll write a little bit about every paper you read. Don't just read a paper and chuck it. Read a paper and then write something about its contribution to your idea. You will finish your thesis proposal, you'll survey the literature, and you'll provide a structured problem statement. And now, what I'd like to do is give you a little demo on how you can use... Why is this not working? That works. Here's Google Scholar, which is at scholar.google.com. This is not standard Google. Some little other thing, I think. Google Scholar has settings. And in the settings, you can map Google Scholar so it does a search to make use of our library and our library's resources, which is kind of important. And what you want to do is you want to set up the Google settings so that you can get I like to get, let's see if we can get this to work. I'll do a search for fast Hartley transforms and do a search. And now in this corner, let's see now, more, find it at Fairfield comes up. I don't know if you noticed, but that's not normal. Google doesn't normally integrate with Fairfield University. In this case, it is integrating with Fairfield. So when I hit find it at Fairfield, it should map into the library database at Fairfield University and allow us to order a paper through the library. A lot of times what happens is papers are held by the IEEE, or they're held by some society that wants to charge us for the papers. I think there is something wrong with my network connection in this room. Oh! I think I know what it is. I'm on the student connections. Let's connect in with FactStaff. When I connect through FactStaff, I have to get authenticated. So now if I go to Google Scholar and do fast Hartley transform, find it at Fairfield. Oh, he's still giving me a hard time. Oh no, now it works. That was the problem. So now I can request it through interlibrary loan, and then I can log in through the IACT system. This is how they do things here. And notice I had already logged in, so now I'm logging in twice. Once you do that, you can request the article. And they will deliver it to you electronically. So all of this is now filled in. It's an article by some guy named Bracewell from the Proceedings of the IEEE. All the information is in place, and now I can submit a request. Turns out I have a number of outstanding requests for stuff already, and you can see my list of requests. Moreover, there are some things which have been delivered. Electronically received articles appear on the left. This is kind of important because it's sort of showing you how to do the research. And now you can see I'm getting all of these, what do they call it, PDF documents that have been delivered by the library to me. You know, I understand it's a little annoying that somebody should sit up here and show you how to use the library, okay? But everybody's library is a little different, and ours is quite peculiar in terms of how it wants you to submit requests. When I have 29 some odd students requesting a couple or three articles per week, right? Think about it. That's 30 students times 3 articles, and they don't have a big staff. So now I've got like 90 articles a week. 10 weeks later, they've processed 1,000 articles, and they're all pissed off at me. They're like, Professor Lyon, what are you doing to us? We have no time for anything. So what we need to do is we need to accommodate them by going through their system, because otherwise they can't keep up. They just can't. So here's something that I got on convolution using discrete Walsh and Fourier power spectra. How exciting, right? And it's delivered straight to me, hot and fresh, and I don't even have to get off my butt, and I can just read it. And this is great. I can print it, I can read it, I can cite it, I can get a proper citation, and this is one of those things where I can say, hey, you know what? I think this is a very interesting problem. And even though the article is from 1972, it might still be very impactful. It might still be very important. And so I can still read the article and make use of some of these ideas that they may have had when they came through and decided to use Walsh transforms for characterizing power spectral density. So it's a real interesting kind of signal processing thing. So, you know, when somebody says, what does it mean to do this kind of research, one thing you might do is you might say, you know, this is the important article I want to cite. I wonder who else has cited it. And if you look at something like this article and you copy it and you put it into Google Scholar, you might find out, you might be surprised how many people have cited it and who most recently has cited it. So if I go in here and I type in this article, and I could say, oh, look, it's cited by 35 other people. So when you're doing research, you say, well, here's an article that's looking important, and it's very old, 1972. If it's very important, someone must have cited it in their research. So let's find out if we can get more recent articles that are related to this thing about Walsh transforms, whatever that is, Fourier transforms. And now I've got a whole bunch of other stuff, and maybe some of that is more recent, like 1991 is way more recent. And I could find that one at Fairfield, or I can get it straight off of another database. Here's one which, you know, instant gratification, right? Instant gratification. I get it right away. There's a PDF document, and it says all I have to do is click on this and go to JSTOR, which is another database that gives me full access, and I say, gee, you know what? It's all in there. And I could just start reading away. So that's kind of cool. And here's another one. He's just going to give me the PDF. Efficient algorithm for blah, 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 blah. Compressive sensing. Doesn't matter so much what it's about. What matters is that you can get it right away without waiting. That's important. And I don't know how long it's going to take me to download it over this wireless connection, but it's not too fast, not too slow. I used to wait for a long time for these things. And guess what? It looks like it's a master's thesis. So then you've got somebody else's master's thesis to look at in the same general field of interest. It says here, I don't know if you can see it back there, an efficient algorithm for the total variation, regularization, single pixel, blah, 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 blah. And presumably they've got a proper thesis in here. And at the end of the day, they've cited a whole bunch of articles, including the one that we started with. And there's their citations. So that's kind of interesting. They wrote 85 pages. You know, there's no minimum. A thesis can be very short. It doesn't have to be 85 pages or 100 pages or whatever. But 85 pages is probably typical for a thesis. Probably typical. So you're into a big writing project if you decide to do a thesis. So what we'll do is we'll get you writing about some ideas for your thesis. Does anybody have an idea already about what they might like to do for a thesis? No idea. My ears are perking up because I see you going like this. And it's only to scratch, right? It wasn't to raise your hand. Are you raising your hand? No, your hands are here. You're going like this now. You're not going to move your hands. I thought I saw you out of the corner of my eye going. All right. Anybody got some ideas? All these bright young people? No ideas? I have no idea. You never had an idea? No ideas? How about an idea for starting a business with your new thesis? No ideas? Yes? Wireless charging of mobiles. You know, we're working on this as a thesis, as a senior project now. And I have 2 graduate students working on it. They use fractal antennas, and they're transmitting power wirelessly. It's a great idea. I had a student work on the thesis proposal for it. It's called Wetricity. Yeah, wireless electricity.
I have seen some effort that power can be transformed from with some, I don't know, but I don't remember, but I have that PPT.
It's typically called RF power harvesting. And when you think about RF, it's, you know, usually higher frequency stuff, but some people use AM.
Conversion of thermal energy into the electrical energy.
Well, if you're talking about low power energy harvesting, you can harvest from solar, from thermal, and from vibration. And so for low power energy harvesting, it's very good if you're in a place with high, I'll call it excess energy. Like, for example, in a helicopter, it's vibrating all the time. So if you have a piezoelectric energy harvesting system on an RFID tag type processor, you can make a distributed sensor system. But that's assuming you have constant vibration, which you do in a helicopter. But that's very specific. Solar, you have to have light, or else it's not going to work. With RF power, it can charge continuously. There's an awful lot written about RF power harvesting. Tons of stuff. So here's 87,000 articles, real articles on RF power harvesting. And then the question becomes, what frequency should you use? What antenna design should you use? Whether or not you want to use something that is an unlicensed power, or whether you want to use just the ambient RF energy around you. Some people use UHF stations because they're so powerful and they're already there, and they can just pick them up. So there's a substantial number of different places where you can use these sensors. And when you manufacture a printed circuit board, you can put it onto a flexible membrane, and you can make it as thin as 4 mils. And people will make it for you. So it becomes like a piece of paper, and you can just stick it into different places and put your sensors all over the place. That might be very good in a helicopter. Helicopters nowadays don't use metal. Isn't that weird? In the days of Vietnam, I used to work at Sikorsky. They had titanium blades, titanium metal blades. And what they did was they take a sheet of titanium, a rectangular sheet, and they put it into a jig, and they would roll it into a cylinder. And then they take a welding system, and they would weld all the way down and make a single hollow cylinder. And then they take the whole cylinder, titanium cylinder, put it into a hydraulic press, and they go whack, and they'd stamp out an airfoil for the main rotary wing of the helicopter. Now it's made completely with laminates, and it's graphite and Kevlar with different weave angles. And they use all the structures made with this way. Has low radar visibility, very low weight to strength ratios. It's very high. It's very strong, very light. But there's a problem. And the problem is they leave these things in the field for much longer than they were intended to. And as a result, they don't know if they're going to be shaking themselves apart or having structural failures. So having sensors all over the place would be great, but if you have to wire them with power, that's not so great. But if you can harvest vibrations, oh, that's great, because now you can just stick these sensors all over the place and they can go and transmit back the stress and strain information back to a centralized computer. Great application. And because it's a very small market, a niche market, you can charge a lot for that. It's a business. So you can have interesting applications for things like energy harvesting. And there are already, I'll say, multiple chips, evaluation boards available so that you can go and start to build things directly and prototype stuff. Which, that's a nice, fun application. Great thesis. You can even get grants in this. NASA has Connecticut Space Grants, which you can do collaboratively with Sikorsky, and that stuff can pay your tuition, right? And a stipend. So if you get involved in doing these kinds of things, and they have direct application in industry, you can get funding, which is really important for some people, right? Getting your I'll say, education paid for. So one thing Sikorsky is very good at is it's very good about paying for its employees' education. They don't just pay the tuition, they pay for the books. Right? They basically pay full freight. And they give you a stipend. So it's very good if you can do that sort of thing. Also, it's very difficult to work at the site at Sikorsky if you're a non-U.S. citizen. So because it's a secure location, it's better if you work at the university and do it through a grant than if you try and get into Sikorsky, because if you're not a U.S. citizen, they won't let you in. Unfortunately. Some companies are like that. Yeah. So now you've got a little insight into how to do the research. I think that's good. Let's see if I can do this. If I click here, keep my place. So you're going to survey your literature. You now know a little bit more about how to do research with Google and with our library resources. You should also know that there are a number of different databases available in the library. I don't know if you've seen that. It's available directly on the website. I'll show you real quick, just in case you're thinking you want to get a jump. If you go to Fairfield EDU, oh look, there's no class. Class is canceled. Ah, no, we're in session. It's okay. Class is not canceled. There should be a place in here that says library. One would hope. Find library. Oops, L-I. Oh, there it is, library. And now if you go to the library home page, you can find the databases. And now if you browse them alphabetically, you can see there's a lot of them. Tons of databases. I'll try one. This one starts with a W and is called WorldCat. And what I'll do is I'll search for a nice book on, pick a subject, your area of interest.
Wireless communication.
Okay. Wireless communication. Want to narrow it down? Maybe using Bluetooth or near field communication or Wi-Fi or just wireless communication. Okay. That's such a broad topic. Okay, there's only 20,000 books in the area. Would you like to read them all now? No. Well, I'll just click on books and I'll limit it because it's too many. Let's limit it by year. So what we'll do is we'll just pick books that were published between year 2013 and year 2014. New books. Brand new books. And now we're down to only 566 books. That's it. We'll select just the English books. And now I think maybe what we'll do is not for kids, not thesis. So how about, oh, I know, not fiction. And I don't care about the format. Clicking on books. If I click on books instead of all, audience not juvenile, not thesis, any format, search. So now we're down to only 433 books. Kind of a big topic you picked. Wanna limit it some other way? How about if we limit it by subject area? Networks. That's only 16% of the books. So that's pretty good. Now we're down to 40 books, all within the last year. And what we'll do is we'll just sort of quickly scan them and see if there's anything interesting. Oh, green communications. Green. Who would have thunk it? Look, green networking. Oh, I don't have that book. And the library doesn't have it either. But I'll get it from another library. So I'll order it on interlibrary loan. I know I've already logged in once on this thing. He's got all the book information populated. And I'll just hit submit request and it'll order the book for me. So if you needed a book and it wasn't in our library, most of them are not, right? Our library is a very small library. Then in general, a newer book won't be there, something that just came out. They'll have to get it from another library, so you put in an interlibrary loan request. How long will that take? Takes time. They have to physically transport the book by mail. They mail it. So a week, sometimes 2. And then you get a note to come pick up your book. So if you found that there was a book that you wanted and it wasn't in our library, and most of them aren't, you must order it by interlibrary loan. And that is a perfectly valid way, and perhaps an important way, for you to go about getting other materials. Materials that you won't find on Google, materials that you won't find on the web easily. Like that book is not on the web. But you can order it for free. It's part of the service you get for your tuition. Free. So you should take advantage of it. And it's a readings course. So it's part of your coursework. So they can't give you a hard time about it. Your professor told you to do it. Yes, you've got a question? You sure?
Yes.
Okay. You can ask your question. Let's see what else we got here. Oral presentations. You will be subjected to a number of painful oral presentations because some of your colleagues are really bad at making presentations. And so what will happen is your presentations will get better. And you'll be grading each other as you do your presentations. And it's one of those things where it's very good to get good at presentations with a group that you're familiar with. It shouldn't make you as nervous as if you're presenting in an industrial setting in front of your boss. Right? I'm not your boss. I'm just a guy who gives you lectures and grades. So what you need to do is you need to get over your fear of presentation if you have one. And it's a very common fear. So then comes this other question. How do I pick a topic? Well, it's the Goldilocks rule. It can't be too hard, okay? But it can't be too easy. It has to be just right. And that's so important because if you pick a topic that's too hard, you will never finish. And it's very important for me as your thesis advisor to advise you to take a topic that you will finish. That's very important. And as you know, a lot of times graduate students have a very aggressive way of selecting a topic, and I say, no, 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 there must be unfinished problems when your thesis is done. You can't solve the world's problems in your thesis. Maybe just one little problem, and that's it. So this is one of those things that's kind of hard. It's almost an art, picking a problem that's correct. So if you said, I'm going to do a thesis in wireless communications, you may have it'll be in the area, but you've got to pick something a little bit more narrow. You can see you can't go through the 40,000 books that you found, right? No one person could. I couldn't. So if you said, well, it's not going to be wireless communications, it's going to be wireless energy transmission. Oh, okay. Now we've got, instead of 40,000 books, maybe we only have 40 books, and that's doable. You can almost look at that. So that's a key element. Narrow it down. You got to have a thesis advisor, and you could do something that's work related if you've already got something in mind. I was looking at theses over in one of the schools over in Hartford, RPI, and I saw there were several theses that came right out of industry, out of GE. Some were about elevators, because there's an elevator company over there called Otis. Some were about jet engines, because there's a jet engine company over there called Pratt & Whitney. But they were industrially based theses. That's perfectly okay. And when you decide to propose a thesis and you say, I want to do something on wireless power charging, do we have what you need? If you said, well, I really want to work in the area of 5 gigahertz, I could say, well, we don't have an oscilloscope that runs at 5 gigahertz. How are you going to be able to test your antennas? How will you be able to test, your power harvesting system? Do I have to go spend $12,000 on a new oscilloscope in order to support you? In fact, I just did. So that was for my senior project students. And it's just one of those things where if you have to wait for us to get something, it could take a while. Our senior project students wanted to have this oscilloscope back in September. Well, we only just got it, so it took a while. But at least we got it eventually. And now we can measure out to 10 gigahertz, which is a very respectable frequency for an oscope. Let's see now. If you've got a killer application, maybe you've got something that could be the next Facebook, or the next Google, or the next, LinkedIn or something. That's great. You should be able to think about what the market is. And then the other thing is, how do you bring something to market? Has anybody here ever brought a product to market? Never? Never? Has anybody here tried to start a business? Just try? No, never. Does anybody care about entrepreneurship in this room? No? Nobody cares about business? Oh, okay. Well, I won't talk about it then. We're having a presentation. I'll mention this to you once, and then you can either go or not go. It's not a requirement of the course. The next presentation we're doing will be here on campus, and John Seifer, the business advisor of CEO Boot Camp, is going to talk about commercializing your idea. That's a week from tomorrow. So it'll be on the 29th, which is Wednesday, over in the Dolan School of Business, and he's going to be presenting at 7 until perhaps 8 or 8:30. And if you want to go, you're certainly welcome to. It's free. I am the president of the Inventors Association of Connecticut. And so I go to these things. I help sponsor them. If this is something that's of interest to you and you want to learn about the commercialization of innovation, these are the kinds of meetings you should go to. If you want, you can take a look at some of our past presentations. If you noticed, the website, the holiday party, has the dean with the governor and the president of the university on the cover page. And that was the holiday party for the Inventors Association of Connecticut last December. So this is sort of an interesting idea. You know, we've got these things going on. There's synergy with the School of Business and with surrounding businesses. So if you want to get a job, the best way to do it is to network. People should be able to see your face, and then they know who you are. And if you are introduced to the right people and they are interested in you, maybe there's a way for you to get a job out of it. So for no other reason than to get your face out there and to start to meet some of the people who hire, because we've got business people coming in. This is a great way to go and show your face and do your networking. Sometimes getting a job means being in the right place at the right time. You know, when I was in industry and my contract was winding down and I was hanging out at the coffee station by the water cooler, and somebody was looking for somebody to do some work, and I said, I'm available, my contract is expiring, and blammo, I was able to take one contract and go to another one without any downtime. And so this is one of those things where you know, networking is so important. So I just thought I'd throw that out there for you. I'll tell you another one I got. Here's a sort of a little aside. I was interested in bringing a product to market, and you could check it out at in my new store. And I featured it on a crowdfunding site called Kickstarter. Has anyone here ever heard of Kickstarter? You never heard of these things? Crowdfunding? No? What you do is I had this little board, and I thought maybe people would want it. So I created a video and offered it for sale, and then I got a whole bunch of backers. And once I got funding, I had, you know, within 60 days, 227 customers. And then I thought, well, this is great. Let's just manufacture. And so we ended up making 400 of these boards, and we sold everything right away because they pay first and then they get the boards later. And this is one of those things where my first project with Kickstarter was very small, but I think in the future you could do much larger ones. And I've seen Kickstarter projects take off with over $1 million. Just remarkable. Great way to jumpstart a business. Removes what I would call the inventory risk. That is, the risk of having unsold inventory sitting in your living room, because what you're doing is you're selling it all in advance. And so that's what the Kickstarter concept is about. And this could easily have been somebody's thesis. It's a signal processing widget that you use for embedded systems. Oops. So here's some ideas. I had one group of students work on what's called grid computing. Anybody here know what grid computing is? Ever hear of it? If you have a bunch of computers sitting around like we do here on campus, usually they just sit around and throw off heat and depreciate, and they sit unused. Right? But if you can run a screensaver that allows them to volunteer their CPUs, then you can create a supercomputer. And so that's what this is screensaver-based computing. So the computers will volunteer themselves into a large grid, a network of workstations. And then you have to write programs that automatically take sequential code and turn it into parallel code. I have some papers on this. I was doing some work over at Norden, which is Northrop Grumman. They make radar systems, and they use embedded supercomputers called Mercury computers. And those led to a whole series of different interesting parallel computing projects. And one of the projects that we had was on vectorization. Have you heard of vectorization? Vectorization is when you take a problem and you try and convert it into something that can work on what's known as single instruction multiple data, or SIMD type architecture. That's a DSP, or digital signal processing type architecture. So if you have all the data and you want to be able to do a single operation on this long stream of data, like multimedia programming, you can use special hardware for that and accelerate the operations. That could be an interesting thesis. A thesis that's got a good industrial application. A thesis that people would pay you to work on. I met with a guy. He runs a small firm out in New Haven. He really wants to build very high-end audio amplifiers. Presently, he ships 6 preamps per month. That doesn't sound like much. Each preamp costs $22,000. That's a staggering amount of money for a preamp. Then he also sells amplifiers. The amplifiers are 2,000-watt audio amplifiers. And he played one for me. They're really loud. And he says, I'm missing certain things that I really want. I want an app that'll control it from my iPad. I want an app that'll control it from my Android phone. I need somebody who can do some programming with a microcontroller. I need, they're very needy, these businesses. They need people to do these things for them. So you can make a thesis out of that, and he'll even pay you for it. So there's a compelling argument to picking a thesis that's attractive to industry. Here's a thesis that was proposed called about steganography. This is hidden writing. When you want to take the data that you want to communicate and you hide it somewhere. It turns out ancient Romans used to shave the messenger's head, and they would write the message on their head, and then they would let the hair grow back in, and then they would send them on their way. No one could find the message. It was hidden writing, right? You had to shave your head to read the message. Well, it turns out you can take, if you have an image, you can hide the message in the noise inside the pixels. That's called steganography. Steganography means hidden writing. And so there are interesting ways in which you could have a thesis just on hidden writing. And maybe you can communicate using hidden writing, and perhaps the NSA can't listen in. Right? Oh, that's very good. I like that. And if you've got a signal processing board, maybe you can use it on your cell phone so the NSA with its Echelon program can't spy on you. So then you could have a new secure cell phone system, kind of like Skype, voice over IP, only you're doing your signal processing, you're scrambling everything. No one can intercept your calls casually and listen in on what it is you're talking about. Great thesis topic. Now that I think about it, I should probably patent it. Oh, which reminds me, you guys will learn about patenting in this course and how to nail down your intellectual property so that your stuff becomes yours and you can license it to others. And then they have to license it from you. Hardware design language. Anybody here taking advanced digital design? Yeah, got a couple? That's a hardware design language type course. They use VHDL. All right, VSIC hardware design language is a completely different language from, let's say, Java or C#. Not the same language. So wouldn't it be nice if people who knew Java could take their programs and convert them to VHDL? Well, that's a great thesis topic. What a great topic. Love to have somebody work on that. There really is nothing out there like it. And in fact, if you had a good way to do it, you got a product you could sell. You know, there's another compelling argument for working on something with a market. I've got a biomedical device I'm working on. It's a rangefinder that uses diffraction. It's a whole new mode for range finding. They call it metrology. And this is a device that goes in the body and allows you to do operations that are minimally invasive surgery. Biomedical devices are very big here in Connecticut. We're like the Silicon Valley of biomedical devices here. And so what you find are very large companies like Covidien, which is the U.S. Surgical. You find Fuji Medical is here. You find in Danbury, there's a place called Hologic, which makes 3D digital mammography systems. A lot of biomedical device companies around. And if you want to go down that path, it's a great way to do service to humanity. And you can find things like cancer, and you can have better outcomes with minimally invasive surgery. And maybe there's a business in it. I got another project I'm working on, and it's in an advanced state, and it's called Project Inidium, which is automatic deployment of Java programs. With automatic deployment of Java programs, you get what you call first-class Java programs. I'll give you a little demo. So here are my WebStart applications, 160 applications all deployed automatically. That's impressive. And now here's one. I'll just click on it and it should just start, in theory. I haven't tested this, so if it embarrasses me, and there it is. And so it just started, and now I can go and I can play with myself. There's Professor Lion playing with himself. So instead of running it as an applet, this is running Java as a first-class application which has access to the hard drive and all your files. It's a signed application, so it's considered a trusted application, and it can access the microphone and the cameras and do all kinds of interesting and wonderful things with printers. And in this case, I'm using it to make pretty pictures. So that's an area where I'm looking for people who would like to help, because I still have some stuff I'd like to iron out and make easier. Automatic deployment of these projects requires that you sign the applications, and that's a whole topic about which I've written some articles. And in fact, I'm looking for means of, I'll call it open source signing of jar files, which means identifying the jar files as being yours. So you get issued a certificate, and then what you can do is you can proceed to sign the jar files, and then if you trust me, you'll be able to run the jar files, and you'll know that I'm the only one who signed them. So it's a mechanism of securing Java programs before they run on your computer. Is it break time? I think it's break time, right? We started at 5. It's already 6:15. All right, let's take a little break. Let's see if I can do this. Here we go. Stop.